Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Redefining Human Pose Estimation, a novel approach with keypoint detection. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research areas that we are working for the human pose estimation. So in this particular application we have given a novel approach for the key point detection by the use of artificial intelligence and deep learning. So before moving to the video, let's talk about that what we will cover into this video. In this video, initially we will talk about that in which application areas this pose estimation can be used. Later on, whatever the code is designed, how to execute it, what are the software requirements to do that. Then we will talk about what are the current systems and what additionally we are doing in this proposed method. And finally, the overall experimental outcomes and results will be shown. So let's talk about the application areas. The pose estimation from the human body while directly the use of the computer vision is useful in many of the application areas. Those are currently attaining so much interest. That is for the automation in the fitness, in the gaming systems, for the biomedical application, for the augmented reality, and yes, especially in the domain of like robotics, for the military, for the industrial applications. So here, the artificial intelligence is being deployed in order to identify the pose of the human. So for that, what we have done, let's talk about that. In order to run the code, we will provide you the folder name code. Here you can see under this code, the dataset and all the related files has been placed. The whole code is being implemented in the MATLAB, so you must have the MATLAB software with you. The MATLAB version that we are using here is R2019A, so you can use 2018, 19 or above, but make sure it should be full version or the trial one. So in order to run the code, what you need to do, you just need to go to the folder where the whole code is being placed. You just need to copy the path of the folder and then go to the MATLAB and paste it here. So when you will paste and press enter, you can see whatever the code files were there in the folder, those will be accessible in the current folder. So all the files will be there in the current folder, including the dataset. So from all these files, you just need to run the final code.m file. So when you will press enter, you can see the code will be open in the editor window and the bar is shifted to editor. So in order to run this code, here is a run button. You just need to click over this button and it will start executing the code. So I'm clicking on the run button. You can see here it is asking for me to give the input. So basically we do have the data set that is giving us the information related to the pose estimation to the head, shoulder, elbow, wrist, hip, knee and ankle. So all these joints has been joints data has been used so that we can individually identify that the proposed system that we have designed is capable to work with the variability in the data set or not. So you can choose any of these options. So you just need to enter the number. Let's say I am entering 4, that is for the wrist, and press enter. So it will take all the data from the data set that I am having. So in the meantime this is running, let's talk about the rest of the details. So in the code folder we do have the dataset in which there are two files. One is images, under which the different images from the dataset of the human being is being there. These are 2000 in count. Other folder is visualized, under which the estimated the pose estimated in a labeled form. Here you can see like this, where these joints and labels has been marked in order to all the files those were there in the image set, because in order to train any of the network we must have the labels as well as the data. So from where we have got this data? This data is available on many of the platforms. The dataset name is leads sports pose extended, or you can directly get like leads sports pose. So you just need to write it on the Google. You can directly go to the dataset link. It is given by this website. So here you can see all the information is also available, that which dataset is there, how you can use it with the different platform like Python. Here we are using it with the MATLAB. So the whole data set will be there and you can directly use it. So currently many of the applications has been designed in order to detect the pose estimation. So one of the thing is the people are using deep learning or the machine learning. In the machine learning, it is crucial to identify those point marks, because the segmentation is to be applied, then the specific points are to be taken. So that will be a complex task. Other than that, many of the people are proposing the deep learning architectures similar to kind of us, but we do have the additional uh, capability of training the network in an effective way and getting the higher outcomes. So what novelty we have done is, most of the people are working with the CNN based models, but here we have given a proposed architecture which is inspired from an hourglass. So what is hourglass? Hourglass is like this architecture images. Let's say this is termed as hourglass. It means the architecture that we have designed is uh, getting that data in its original form, squeezing it, then extending it. So broadening and squeezing is the feature of our model that we have designed with the CNN. So you can see here the training is being under process and the number of iterations and all the details are being happening. So the accuracy was initially started from around 0% and now it reached to around 100%. So let's see after the training for the wrist dataset what exactly we get. So it will take some time because the epochs that we have given for the system are 18 count, having the 16 iterations in each, so giving us a total of 1280 iterations, so which is running. So in the meantime, let's see the code. So we do have the data set which we have already read and say individually segregated the information for all the joints. So when we are getting the input from the joints, accordingly we are loading the data set, and then we are doing the pre-processing part where all the images are being uh, resized in order to fed it to the further data set. So and labels are categorized. Then the whole network has been deployed, where the architecture layers has been given in the terms of the hourglass. Initially the image layer is as a input, then convolutional layer, batch, and the ReLU layer is there. So we are reducing the count of the width of the network, so that we can downsample the data up to here. The downsampling of the information is there. After this we are extending it up, which is upsampling. So that is means extending the feature set. So downsampling and upsampling, inspired from this we have developed the whole model. And finally for training purpose we have used a SGDM model, and epochs and all the related information have been given. Finally, when it is done, we are training the network and then evaluating it in order to get the outcomes in terms of accuracy and error rate. So as you can see, the training is about to be finished. Out of 1280 iterations, 1100 something have been already done. So let's wait it to be completed. So you can see, even after 400 iterations, our system is effective enough to get maximum accurate result and being static. So the accuracy currently is around 100 and the loss is around 0. So it is expected that the outcome will be near to the 100%. So that shows the effectiveness of the proposed architecture of the hourglass inspired CNN. So which defend that if the dataset is going to be increased, this architecture will be effective enough to give us the better accuracy results. So currently after this, let's see what outcomes we have got. So you can see for fourth we have got the 100% of the accuracy and the error rate is around 0. Even the same stats can be seen on the training progress, right? So further modifications are still possible into it in order to combine all the joints, and then working on that will be more effective to give a final real term application. So industrial people, those are working in the domain of the artificial intelligence, or the research people, can contact us directly to get the information. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.